The next question is, which of the following is a heterogeneous mixture? Okay, and the options are brass, sugar solution in water, air, and milk. So student, there are two types of mixture, heterogeneous mixture and homogeneous mixture. So you need to tell which of the following is a heterogeneous mixture. Yes, brass is basically a homogeneous mixture, so this is incorrect. Sugar solution in water, it is going to be uniformly spread in the water, so again it is going to be homogeneous solution. And if you talk about air is again a mixture of various gases, basically homogeneous mixture. Finally, you are left with milk. Milk is a heterogeneous mixture, although it appears to be very homogeneous, but milk is a special type of heterogeneous mixture, also known as emulsion, right? So option D is the right answer. So in the theory class, we have seen the chemical classification of matter like pure substance or impure substance, which are also known as mixture. And this mixture can be further divided into homogeneous mixture, and homogeneous mixture are sometimes called solution. And the heterogeneous mixture, there are two types, colloid and suspension. And in our theory classes, we have seen the difference between all of these terminologies, okay, along with the example. Okay, so I'm not going to repeat in today's session. So let's see the next question. The air is what? Option A, pure mixture. Option B, blends only. Option C, mixture of element only. Option D, mixture of both element and compounds. Student, the answer for this question would be mixture of both element and compounds. Air has many gases, okay, and it reacts with sometime many things, so it forms a compound also, okay. So option D should be the right answer, right? Mixture of sand and sugar is an example of what? Okay, so you have sand and sugar. Basically these two constituents are not going to be uniform in the mixture, so it is going to make a heterogeneous mixture, okay. So option A, those who have given, they are right, it is heterogeneous mixture. The heterogeneous mixture in which solute particles do not dissolve but remain suspended through the medium is called what? Okay, so we have seen there are two types of heterogeneous mixture. First one is colloid, second one is suspension. So it is the suspension in which the particle remains suspended, okay, and we have seen the difference in our theory classes, okay. So if you know, you can easily answer that this is a suspension because solute is not completely dissolved but remains suspended in the medium, okay. Let's see the next question quickly. Sugar is dash in a sugar solution, okay. So a solution consists of solvent and the solute. So here sugar in sugar solution is basically the solute. What about the solvent? Solvent is the water or any other liquid, okay. So solute, sugar is a solute, water is a solution, okay. So option B is the right answer. And the important concept about solution is that it is a homogeneous mixture, okay. And like it is not only the case like only solid in liquid like sugar in water, it can be gas in liquid also. Like if you drink some cold drink like soda water, it consists of gas like CO2 and water, again it is a solution. Gas in gas solution is also possible like air. Air consists of oxygen gas, nitrogen gas, and similarly many other gases, okay. And we have seen the component of solution. So there are basically two components. First one is a solute, which is basically present in the lesser amount. The other one is solvent, which is basically present in larger amount. In very simple case, salt is the solute, whereas water is the solvent. And if you combine these two, it becomes a solution. And we have seen the formula for finding the concentration It can be mass by mass percentage, mass by volume, parts per million for very dilute solution. Okay, I'm not going to discuss about these components in detail in today's session. Our agenda is to solve the previous year questions. Okay, when two liquids do not dissolve each other and do not form solution, what is it called? Okay, so you have two liquid but they are not forming a solution. It is basically called immiscible. Okay, immiscible. Okay, like if you put oil and water, they are not going to dissolve each other, so they are immiscible liquid. Okay, immiscible liquid. Okay, so option C is the right answer. A very important one I am marking is an important one. Milk is an example of what? Okay, milk is a special form of colloid called emulsion. Okay, milk is emulsion. Okay, milk is an emulsion. So option C is the right answer. And we have seen milk is basically an emulsion, which is a special type of colloid when dispersed phase and dispersed medium both are liquid, so it is emulsion. Okay, so colloidal, we have seen that the size is between 1 nanometer to 1000 nanometer, and this colloidal solution shows Tyndall effect. Basically it is a scattering of light. So all such pointer we have seen in our theory class. Yes. Which one of the following process is not useful for the purification of solid impurities? Okay, distillation, sublimation, crystallization, all of the above. Student, you should remember that distillation is the process for separating the mixture which are generally liquid in nature. It is not going to help for those substances which have solid impurities. So option A is the right answer. And in the theory class we have seen there are different ways of separating the mixture for homogeneous or heterogeneous. Okay, so when two immiscible liquids are there, this fractional distillation is used, and generally it is used in the petroleum refineries. Okay, this is a very important one. When two miscible liquids have close boiling point, then fractional distillation is used. But when two liquid have a huge boiling point difference, then distillation is used. Okay, and there are many ways of separating the mixture. Okay, so this thing we have seen in our theory class. Okay, the technique of chromatography is used to what? Okay, identify the colored substance, determine the structure of substance, dry distillation of color substance, separate substance from mixture. Okay, it is basically the separate the substance from a mixture. Chromatography is used. So we have seen in the previous slide that separate the substance based on the absorption rate, basically like colors in the ink. Okay, so if the substance have different absorption rate, chromatography is used. The next one, water passes from soil into roots by physical process called what? Okay, so this is the plant, so this is a root. Okay, so water grows from soil to the plant. What is this process called? So you have two options, like you can see transpiration or osmosis, but the correct answer is option E, more than one of above. Osmosis and transpiration. Okay, both you can tell. This is the thing. Okay, so option E is the right answer here. So we have seen the difference between diffusion osmosis and reverse osmosis. Difference is very minute, but you should be very cautious. The first thing you should know that diffusion is basically the high concentration to low concentration. Okay, for example, when you have a perfume in your room and you spray it, it smells throughout the room. Okay, so this concentration is going to be increased from high to low concentration, and in such cases membrane is not needed, no external pressure is required, and all the substance particles move. Okay, example, the smell in like ink spreading and many more. The next one is osmosis. It is the reverse of diffusion, and it is basically moving from low concentration to high concentration. through a semi-permeable membrane, so membrane is needed, and in the osmosis external pressure is not required, but in RO, that is reverse osmosis, external pressure is required. Okay, and in osmosis you have example like water is going from plants through root, and in the water purifiers this reverse osmosis RO is used, where high concentration to low concentration movement is there of the solvent. Okay, and in such case external pressure is required. Okay, so diffusion occur in the extreme intensity in which of the following state: solid, liquid, gas, plasma. So just now I told you that it is basically the gas. Okay, so you have like high concentration of the substance, so when these are going to be diffused in the gas, it is going to be highly extreme intensity. Why? Because molecules are very free to move anywhere in the gases. Okay, so option C is the right answer.